Okay.
All my papers, like they're very cool. I have like
5.
Alia, bounce off for we could join 322 class. We join class Anita.
Okay.
Anita.
Class rep.
That is crazy.
Abrazak. Abrazak, can I hear you? Please, everybody should move themselves. Abrazak.
Why? She's calling you.
So the class rep is not on ground. So Abrazak is not around. It's taking that he's not around. Okay. Please make sure you're muted throughout this class. So good morning, class.
Good morning, ma.
I want us to quickly do something today so that today will not be totally wasted. So we're going to talk on salicylic acid. Using acid, how to prepare carboxylic. In today's class, we're going to be looking at dicarboxylic acid. So from the word dicarboxylic means it has 2 carboxyl functional group. Okay. So this is generally important product of fatty acid because they originate from oxidation. Remember, acid is a product of oxidation. Dicarboxylic acid are suitable substances in preparation of organic acids. They are very useful materials in the industry. You can see them in fragrance industry. You can see them as lubricants, as esters, as amides, and as adhesives. So they're very useful compound to be talked about. General formula of dicarboxylic acid is as shown on the slide, CH2N, then plus carboxyl functional group at both ends, meaning that my methylene can be more than 1. So we're going to know some of the examples of dicarboxylic acid. You're going to understand their IUPAC names, and you're going to understand their generic name. You also understand how they can be synthesized and some of their reactions. So that's what we're going to be doing in this particular class. 2 carboxyl group on a benzene ring indicate phthalic acid. So dicarboxylic acid is not only for aliphatic compound, you can also have them in aromatic compound. Now, these are the typical example of dicarboxylic acid. We are having like 6 compounds here. Now, if you look at the table, you can see the number of carbon chain, the structural formula, the common name, and the IUPAC. You are expected to know this table the way it is here. Number of carbon chain is like talking about how many N. Okay. In this one, in the first one, we can see the carbon acid we have is 2. So in another structure, you can talk about, instead of number of carbon chain, you talk about N, because dicarboxylic functional group is a constant. What differs there is N, the methylene. So the first carbon, the first compound is when N is 0. You can see there's no N in that first compound. So we just have 2 carboxyl, no methylene in between. The second is when N is 1. Then when N is 2, when N is 3, 4, and 5. So there's an acronym we use for that. When N is 1, we call oxalic acid as common name. The IUPAC name is ethane dioic acid. Remember, by virtue of ethane is because carbon is 2. That's what we call them ethane. So the IUPAC name, you give the IUPAC name by virtue of the number of carbon. Then put dioic. So you can see when N is 3, malonic, we call it propane dioic. Now, some of the mistakes students make is in spelling of dioic. Dioic is D-I, then O-I-C. Normally, if you want to talk about carboxylic acid to carboxyl, we are using di before the oic. Please make sure you practice it to understand the spelling. Now, the alkane compound there, we are going to name it to the end. We have ethane because when carbon is 2, it is called ethane. So we call it ethane that has 2 carboxyl functional group. That's why I call it ethane dioic acid. When N is 3, we're talking about propane dioic acid. When N is 4, is when carbon is 4 because N is 2. So remember, the IUPAC name is value of number of carbon, not number of N. So now, there's an acronym we use for this. Oxalic malonic succinic, glutaric, adipic, and
Maya, you're muted.
But we can't hear you.
All this is I was saying, you were not hearing me.
No, ma, we were not.
Okay, sorry. I never know it was muted. So I was talking about that according to the table here. Oh my, such good apple pie is a hint we use whenever we want to remember accordingly, sequentially, the first 6 member of dicarboxylic acid. So whenever you ask a question, it should represent the first 5 or first 6. It must be sequentially, accordingly. So when you mumble it up, you started failing already. So that's why you have to be consistent in practicing so you don't miss anything. I stress on this IUPAC name. Whenever you want to write dicarboxylic, that alkane compound must be written in full. Then you end it up with dioic. Remember, when you want to talk about carboxylic, you talk about propanoic, OIC. But because we have 2 OIC, we call it dioic. And the alkane will be written in complete. That's why you have ethane. Some of you, when they were writing, they will skip the E. You're not skipping it, you're writing the alkane in full. And so that's why, so when we are talking about number of C, it's going to help you in knowing the alkane. That is the IUPAC name. Because when C is 2, we call it ethane. So this one is ethane that has 2 carboxyl functional group. We call it ethane dioic. And others, as you can see on the slide. So you're going to use oh my such good apple pie as an acronym to remember that oxalic come before malonic, and malonic come before succinic, glutaric, adipic, and pimelic. These are the sequence. Maintain the sequence. And some of the mistakes people normally make is whenever they want to write the structural formula. Remember, it is carbon connecting to carbon. It is wrong for you to write CH2, COOH, and the other, and by my left, we write COOH, meaning the hydrogen will end and connect to the middle carbon or the next carbon. So it is not like that. Let there be carbon connecting to carbon. That is what it's supposed to be. Because when you do that, when you do the other way around, you're giving hydrogen more valency, like 2 valencies or more than that. But it is not supposed, hydrogen is supposed to maintain single valency. So it's supposed to be terminal. So make sure you look at the structure form very well and don't miss it up. Okay, so in the exam, you might be asked to talk about a table. In that table, you're going to talk about N, the number of N, which means the number of methylene. Okay, then before you talk about the structural formula, the common name, and the IUPAC name. The number of carbon length of carbon is for you to know the IUPAC name. That is the alkane group where it belongs. So please, let's be consistent and conversant with this particular table. So this is about nomenclature. If you look at this is nomenclature. You talk about that at the end of alkane, I'm going to add dioic, like I said in the previous slide. So that's why we have ethane dioic, propane dioic. So my alkane will be written in full. Then I'll end it. I add a suffix, which is dioic, 2-carboxyl. Okay. Okay. So if the carboxyl group is bonded to a ring, the name of the compound, you're going to name it and add carboxylic acid. People that did 319, you'll be conversant with this. That's why we have 2-cyclohexane carboxylic acid. So if it's look at the other one, we have trans. Why is it trans? Because you can see the carboxyl is one is stressed, one is dotted. So trans 1,3-cyclopentane, because the compound is cyclopentane, and 1,3 is the position of the dicarboxylic, and they are in trans isomer. So at the end, I put dicarboxylic acid. Okay, because I have 2 carboxylic acid. The first one is carboxylic acid because I have 1 carboxylic acid. Okay, so look at this one. We have benzoic acid, This is the simplest aromatic carboxylic, but not dicarboxylic. We have hydroxybenzoic acid. Then we have dibenzoic acid, which is 1,2-benzene dicarboxylic acid. Now I'm naming dicarboxylic acid differently. Benzene is like the alkane. Okay, so that is how to do it when you're dealing with ring. You end with carboxylic acid if it's 1-carboxyl, or dicarboxylic acid if it's 2-carboxyl. They indicate the position of this dicarboxylic acid. Okay. Now, like this, just trying to stress on the table. When N is 0, we have oxalic. When N is 1, malonic. N2, succinic. N3, glutaric. Adipic 4. Pimelic 5. Suberic 6. Azelaic 7. And sebacic 8. And these are corresponding structural formula. We have a molecular. This one is a formula in the molecular form. If you're talking about structural formula, you're talking about indicating the linkage of carbon atoms, hydrogen, and oxygen in the ring. But this one is a formula. We call it molecular formula. We look at how it is. It is aligned in the sense that you know that carbon is catenating with itself, not the other way around. Please, some students normally make that mistake. That's why I'm stressing on this. Understand how this is written is very important. Okay, don't mobile it up. Well, that's the sense of having the class work, that we can have a hands-on on this. Okay, these are the trivial name of dicarboxylic acid. This is talic acid. Talic acid is when I have dicarboxylic acid at position number 1 and 2. So another one is when I have it at position number 1 and 3, I will call it isotalic acid. Position 1 and 4 is teratalic acid. So ortho position is 1 and 2, which is making it talic acid. 1 and 3 is meta position, making it isotalic acid. 1 and 4 is para, making it teratalic acid. Okay. We are still trying to stress on what we've said before. Okay. At the end of the parent chain of alkane, we're going to add dioic in terms of the IUPAC naming. Now, acidity of dicarboxylic acid. Now, one carbonyl group in dicarboxylic acid is acting as electron withdrawing group towards the other one, okay, which lowers its pKa. The effect decreases with increasing separation. Okay, now if you look at what we have in pKa, remember, the higher the pKa, the more the acidity. And remember, distance affects acidity. If you look at oxalic acid, there is no methylene in between them. That's why it has the highest acidity.
So you're not doing what I can hear. It's my network.
Yeah, I don't.
No,
Guess
no,
you
it's
logged up.
general, it's general.
This network is something else. Apologies. So the strongest of the dicarboxylic acid is oxalic acid because there's no methylene in between them, meaning that the electrostatic force of attraction is being felt more, okay, because the carboxyl are close together, so they're feeling themselves. Now, how do we prepare that carboxylic acid? We're going to look at one or two preparations. How do we prepare this dicarboxylic acid? One, by oxidation of benzylic at benzylic position. Now we have paraxylene under oxidation. Remember, when methyl is oxidized, we are going to form carboxylic acid. If you look at the story of toluene, under oxidation is going to give benzoic acid. So that's the same thing that happened here. So we are using paraxylene because paraxylene is 1,4-dimethyl. Okay, under oxidation, we are going to form terephthalic acid. And this terephthalic acid can also undergo esterification reaction to form an ester. And this ester is a compound called DMT that is being used in the industry. Okay, so the essence of this is for you to know that all this issue of dicarboxylic acid is a very useful chemicals for our industries. This slide seems to be very incomplete because we also have other methods of preparation of dicarboxylic, which I'm not seeing here. So this is a very incomplete slide. I'm going to share another slide. This slide is not complete. So in the summary of today's class, we understood that dicarboxylic acid is a compound that have two carboxyl functional groups. And this carboxyl functional group are at the both ends of the compound. And we also talk about that dicarboxylic acid cannot be only in aliphatic compound. We also have them in aromatic compounds or cyclo compounds. And we talked about that dicarboxylic acid, we have an acronym to remember the first 6, which is oh my, such good apple pie. And we are expected to know the number of N, the formula. Now, in the exam, if the question is structural formula, you have to write structure. This one, what is written here is not structure, it's molecular formula. So for you to understand, if you're talking about structural formula, you indicate the connection of carbon and oxygen and hydrogen and their linkages. So this is molecular formula. So if the question said formula, you can write anyone. But if the one says structural formula, you have to draw. And if they say formula or molecular formula, you can use this one as shown on the slide. So we'll talk about their Shriver name or common name and the IUPAC name. It is a must that we're going to know it. And then we discuss how to name them. Then you have to make sure that the parent name of alkane is being named completely before you add dioic. Okay? And we talk about whenever we're having aromatic or ring, we're going to name it as a ring, then add carboxylic acid if it's for 1, or dicarboxylic acid if it's for 2. And when we're talking about dicarboxylic acid for a ring, we are going to indicate the position of this carboxyl functional group in that ring. Okay, and we talk about the preparation. The method of preparation that we talked about today is using oxidation. Okay, and also we talked about the effect of methylene on acidity of this dicarboxylic acid. That the farther the more the N, the weaker the acid. Meaning that a compound that has no N, like oxalic, is the strongest of all because of the closeness of the carboxyl group. And one of the method of oxidation preparation we talked about today is simply oxidation using paraxylene. So in the next class, we're going to look into details of the preparation and the reactions of dicarboxylic acid. So course rep, if there's any other time we can fix, other than tomorrow, anything from 11:30 to 1:30, I'll be in a class. So before and after is fine. For if it's a doable thing, we do. If not, we'll continue like our schedule next week, Wednesday. But I'm going to share the assignment for today on Google Classroom. Make sure you log on to check the assignments and submit as we used to do. Thank you very much. Let me know if there's any question in the house before we end the class. Unmute yourself and ask question if there is any need, if need be. Any question? Do we have biochemistry students in the house? Are there biochemistry students?
Yes, ma'am. Good
Okay, how many are
afternoon.
you? Good afternoon.
Well,
Biochemistry
3, ma'am.
students. 3. How many are you that are writing the course?
Yes. Yes, ma'am. Yes,
Is it
ma'am.
okay? Only 3 of you are writing the course.
Yes, ma'am. We're 3 at the moment, ma'am.
Okay, fine. So because I learned of your challenge of Wednesday class, so that's why I said if you must avail yourself of Thursday class and look for somebody. Some of the classes we had something online on them, okay. But if not, go through the slide, look for any of the chemistry person that can put you through. And whenever you feel it's possible, make sure you come to class on Wednesday. Okay. Thank you, everyone.
Okay.
Thanks for
Yes,
coming.
ma'am. Thank you, ma'am.
See you in the next class.